Unit 5, we're going to focus on the objective of identifying metals, nonmetals, and metalloids, as well as families on the periodic table. So first, a little bit of history about the periodic table. There were many people attempting to organize all elements into some sort of chart or table, but there were many failed ones. Dmitri Mendeleev, in the mid-1800s, he's considered the father of the periodic table because he's the first one to organize it in such a way that still is found today on our modern periodic table. So what he did first was he took the 70 known elements at the time and he put them in order by increasing mass. Then he placed elements that had similar properties in vertical columns with each other, and then he left blank spaces where he felt elements should be placed that hadn't yet been discovered. And so here is his periodic table, increasing mass from left to right and top to bottom, as well as in columns with similar properties. Now, fast forward to 1913, Henry Moseley discovers the atomic numbers for the elements, and so he made the modification on Mendeleev's periodic table where instead of arranging them by increasing mass, now they're arranged by increasing atomic number. Elements with similar properties are still in the same column, so since that part of Mendeleev's periodic table held true till today, that's why he's the father of the periodic table. So today we are organized by increasing atomic number and in columns based on similar properties. So a little side bit about Henry Moseley. He wanted to join the British Army in World War I, but his family and the government pleaded for him not to. He fought really hard in order to fight in the Army and then died on the front lines at age 27. So after his death, with the help of Ernest Rutherford, the British government banned any scientist of great repute from serving on front lines. So, it's called the periodic table because of its periodic properties. Periodic refers to a repeating pattern like days of the week, months of the year, class periods in a school day. Periodic law is when the elements are arranged in order of increasing atomic number. There is a periodic repetition of their physical and chemical properties. Alright, next up is horizontal rows are periods and vertical columns are groups or families. Horizontally, hydrogen is normally here. This would be period 1, period 2, period 3, period 4, period 5, period 6, period 7, and then vertically, these are called groups or families. So vertically, this is group 1, group 2. We don't worry about groups in the transition metal section or the D block, so we'll skip across to the next tall column. Group 3, Group 4, Group 5, Group 6, Group 7, and then this would be Group 8 or Group 0, and we'll see why later. Groups on the periodic table are going to have the same number of valence electrons. So every element in this group has the same number of valence electrons as the other elements in this group. If you have periods, they have the same number of energy levels. So period 1 elements have 1 energy level, period 2 elements have 2 energy levels, and so forth. So there are two different sections of the periodic table. There's the group A, which are known as the representative elements, and then there's group B, which are known as the transition metals. The representative elements are going to be the S and the P blocks, the 8 tall columns, and then the transition metal section is the D block. Group 1A of the representative elements are the alkali metals. Except for hydrogen, hydrogen is actually a gas, not a metal. Alkali metals have 1 valence electron, which they lose and become a +1 ion. Alkali metals react vigorously with water. Physical properties are they are soft, metallic, solid, shiny, luster, high thermal conductivity, high electrical conductivity, low density, low melting point. So if you throw an alkali metal in water, it will actually catch on fire and then explode, giving off a plume of hydrogen gas. It's soft enough that you can cut it with a butter knife as well. Group 2A of the representative elements are called the alkaline earth metals. So alkaline earth metals have 2 valence electrons, which they lose and become +2 ions, and their properties are they are harder, more dense, and higher melting point than alkali metals. The halogens are group 7A of our representative elements. They have 7 valence electrons and will tend to gain 1 electron to form a -1 ion. Their properties are that they are nonmetals, that they exist as gases, fluorine and chlorine, a liquid, bromine, and a solid, iodine. And then group 8A of the representative elements are the noble gases. Noble gases have filled valence levels. They have stable electron configurations. They are extremely unreactive. They are sometimes referred to as the inert gases because it was thought that they were incapable of forming chemical compounds. So you should color your periodic table or label the family names. So when we have group 1, this vertical column, its family name is known as the alkali metals. Group 2 is known as the alkaline earth metals. Then we're going to skip across. Group 7 is known as the halogens, and group 8 is known as the noble gases. So our vertical columns and groups are the alkali metal family, the alkaline earth metal family. This is the transition metal family or section. Then 3, 4, 5, and 6 are named by the elements that are at the top of their group: boron family, carbon family, nitrogen family, oxygen family. And then we highlighted group 7, which is the halogen family, and group 8, which is the noble gases. At the bottom, we have the lanthanide series and the actinide series. The periodic table can be divided into 3 sections: metals, nonmetals, and metalloids. Metals are here found on the left side of the periodic table, and then the nonmetals are found in pink on the right side of the periodic table. Then we have what's called the metalloids, and they are one side of the box touching the staircase is going to indicate a metalloid. So here's the staircase. It's slightly bolded, and any element that is sitting on top of or below the staircase is considered a metalloid. There is an exception. Aluminum is under the staircase touching it, but it's not a metalloid, it is a metal. Characteristics of metals versus nonmetals. The appearance of metals is going to have luster. It's going to be shiny, whereas nonmetals is going to be dull. The state of matter of metals is majority solids with one exception, and then the states of matter of nonmetals is actually going to in general be gases, though it can actually exist solids, liquids, and gases as a nonmetal. Conductivity of heat and electricity: metals are going to be good conductors of heat and electricity. Nonmetals are going to be poor conductors of heat and electricity. Ductility means that it can be drawn into a wire. Metals can be drawn into a wire, nonmetals cannot. Malleability is the ability to hammer it into a sheet, and so metals can be hammered into a flat sheet, whereas nonmetals cannot. They are solids that are brittle and they would break apart. Metalloids, silicon, boron, germanium, arsenic, antimony, and tellurium, have properties of both metals and nonmetals. I'll label our periodic table with metals, nonmetals, and metalloids. First, I've drawn in the staircase in blue that starts at the top left of boron and it goes down and to the right, 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 and then down. Now I'm going to highlight the elements that are the metalloids. They are boron, silicon, arsenic, tellurium. Notice the 4 on top of the staircase, and then under the staircase is going to be just germanium and antimony. So these are going to be our metalloids. On the left side of the staircase is going to be where all of our metals are found, and on the right side of the staircase is where we will find the nonmetals. Now let's list the properties of each. On the left side are metals. They are good conductors of heat and electricity. They are shiny. They have luster. They tend to usually be hard and dense, and they are malleable and ductile. Can be hammered into a sheet or drawn into a wire. The nonmetals are going to be the opposite. They are going to be poor conductors. They are going to be dull, not shiny, and they are not malleable and ductile. And their states of matter tend to be brittle solids, liquids, or gases. Now let's do a little check for understanding. If you have sodium, potassium, lithium, and francium, and you look on the periodic table, are these in the same group or in the same period? What about nitrogen, arsenic, antimony, and bismuth? Same group or the same period? What about chromium, manganese, iron, and cobalt? Are they in the same group or the same period? Is calcium a metal or a nonmetal? Is nobelium a metal or a nonmetal? And then group A elements are called what kind of elements, and the group B elements are known as the what? And you can unpause the video to see the answers. Number 1 is group, number 2 group, number 3 period, number 4 metal, number 5 metal. Group A elements are the representative elements, and group B elements are the transition metals.